In the previous video, we have seen an overview of quicksort. In this video, we will implement quicksort using recursion. So let me write a function called quicksort, which will accept an array. Since we'll be using recursion, we need to define the base case. Our base case is whenever the size of the array is less than or equal to 1, we need to just return that array. So I'll write if array.length is less than or equal to 1, I'll just return the array. So now we need to find the pivot. In our case, the last element is the pivot. So to find the last element in the array, we can use the at function. So pivot is array at -1. So this at function can be used to index the array with the negative indexes. Negative index start with the -1, -2, and until goes to the length of the array, -11 in our case. So we have the pivot. Now let us declare empty left array and right subarray. So we have already stored the last element as the pivot. So we need to loop until only the n minus first element. So for I is equal to 0 until array.length -1. So what we need to do is we need to check if array of I is less than the pivot. If that is the case, then push it to the left array. If not, push it to the right array. So now what we do with the left array and this is the right array. So we call the same quicksort function with the left array and right array. So whatever this quicksort returns, I will store it in sorted left. So that will be quicksort of left. Similarly, sorted right will be quicksort of right. Now we need to combine this sorted left array and sorted right array and return it. So I'll use the spread operator here, and we should not forget about the pivot. Pivot will come in the middle and the right array will have the larger elements. So I'll spread it and return it. So now let us test it. I'll use the same array as in the example. Now I'll print the response from the quicksort. So as you can see, it is printing the sorted array. So as we always do, let us log and trace the program. So as you can see here, the left is 4312, which is here, and 5 is pivot, and the right is 8, 6, 7, 11, 9, 10. Now it will go to quicksort of this. So it will be 1, 2 is the pivot, and 4, 3. 1, 2 is the pivot, 4, 3. So in the last step here, there will not be anything in the left, then 3 is the pivot and 4 is the right. And now coming to the right subarray, 8, 6, 9 is in the left, 10 is the pivot and 11 is in the right. And coming to this, 8, 6, 7 is in the left and 9 is in the pivot. And finally, 6 is in the left, 7 is in the pivot and 8 is in the right. So that is how we can trace the execution of this program. So coming to the complexity, the best and average case complexity of quicksort is big O of n log n, and the worst case is big O of n raised to 2 since we have two loops. Your program might get into a worst case scenario based on how you choose the pivot. So that's it about quicksort. Hope you liked the video. If you did, please consider subscribing to the channel. In the next video, we will see merge sort.